All right, so today we are going to talk about lines tangent to circles. So in a circle, when a line connects to the outside of the circle in exactly one point, that is called a tangent. So this line right here, A, B, is tangent to circle C at point D. So line AB is tangent to the circle at point D. D is called the point of tangency. So I always like to tell the story or the idea of why did this word actually come about? Or what can you relate to this in real life? If you've ever heard somebody talk about going off on a tangent, generally there is one part of a story that connects them to their tangency of their dialogue. So for example, if I am talking about my dog in class and I talk about how my dog has the prettiest curly hair, and someone else says, you know what, I know about curly hair, and then proceeds to talk about their curly hair or their curly hair experience, that is the point of tangency. The point where we got together was on the curly hair, but then my story about the dog is completely lost and their story about the curly hair takes off. Now, sometimes that's just the nature of how a story works, how we kind of dialogue and interact with each other. But sometimes that's not exactly what we want. So that's the same kind of idea. This tangent is where the circle connects to the line. It's that one point where they really start to talk to each other, or the one connection that they have. So it intersects at only one point. Now, what's really cool is that the point of tangency is always perpendicular to the radius of a circle. So if we connect points C and D, we could call line segment CD the radius. That makes angle CDA or angle CDB a right angle, or it makes this perpendicular or a right angle. Conversely, if I know that it is a right angle, then I know that it's tangent. So that's our first theorem there. That's our first kind of idea in tangency. A, what is a tangent? It's that line that barely touches the circle. B, what conclusions can we draw about our points of tangency? So when we are tangent at that point of tangency, we create a right angle. So we might be given a problem that looks like this, where we're given that the circle is P and that the radius of the circle is 6. We can tell that because the point P and J is on the outside of, or on the edge of the circle, and P is the center of the circle. I know that P is the center of the circle from this part right here because it is called circle P. That names P as the center. And I want to know, is KJ tangent? Well, if KJ is tangent, then that means that this is a right angle. So really, I'm checking to see if this is a right angle. Well, if this is a right angle, then that means that it is a right triangle, and that Pythagorean theorem holds true. And remember, the Pythagorean theorem says that if we take a leg and we square it, and we add it to another leg squared, that should always equal the hypotenuse squared. So in this case, our legs are 6 for JP, and 9 for KJ, and our hypotenuse is 6 plus 4, which is 10. So does this work? Okay, so all we're going to do is check the Pythagorean theorem. So you could use your Desmos calculator, you could use your brain and do 36 plus 81. Does that equal 100? I'm going to go out on a limb here and say no before I even finish up the problem, but if I do finish it up, this becomes 111 and this is 100. So even though these look like they might be a right angle and it looks as though it might be a right triangle, it is not. And so therefore, the answer to this question would actually be no, it is not tangent. Now, we could go a little step further here and we could say, well, what is the relationship between 117 and 100? Well, the hypotenuse is smaller, so this is actually going to be an acute triangle if we were going to have to classify it. All right, this is a fun little problem. Now, I'm aware that our definitions of fun might be different. However, it is a fun algebra type of problem. So, if you have been struggling with those algebra skills, this is a great one to watch. This is given that ST is tangent to circle R. So, that means that this right here is a right angle. That also means that this should be a right triangle and the Pythagorean theorem should hold. So, remember, that's leg squared plus leg squared is equal to the hypotenuse squared. So for us, our leg is x, that's our RS, and our other leg is 24. And then that's equal to x plus 18, which is actually the length of the hypotenuse. Now that x plus 18, remember, we can rewrite that as x plus 18 times x plus 18. So it looks like x squared plus 24 squared is equal to x plus 18 times x plus 18. I'm just writing out that multiplication, and then I'm going to double distribute. So I'm going to do x times x is x squared, 18 times x is 18x. So this is what I'm looking at. X squared plus, this ends up being 576 is equal to, and we're going to go, x times x is x squared. X times 18 is 18x. 18 times x is 18x, and 18 times 18 is 324. Whoops. Now we've got some like terms that we can combine right here in the center. So we get x squared plus 576 is equal to x squared plus 36x plus 324. We're going to solve this equation by canceling out our x squareds. Look at that. When I have the same thing on both sides, so I can subtract x squared, those guys are going to cancel out. So now the equation that I'm looking at is 576 is equal to 36x plus 324. So we've got to look for those patterns and those easy parts to do when we're doing our algebra. Try to make it as easy as possible on yourself. Now I'm going to combine like terms, so I'm going to subtract 324 from both sides, and that gives me that 252 is equal to 36x. Then we divide by 36. And we get that 7 is equal to x. What does that mean? So now we have to interpret our answer. Our answer, that means that the radius of circle R is 7, or that this x is equal to 7. And these two are congruent because they are both the radius. All right, this is actually kind of a cool problem. I struggled with it for a bit, so I think that's important for you to know that these aren't always easy for me either. The first thing I notice is that the lines are tangent. So M and N are both tangent to circle T. What that means is that these two angles right here are right angles. Okay, so I'm putting them in as a right angle symbol. I'm also going to write in that they're both 90 degrees. That's going to help us here in a second. Okay, this is one of the problems I really like because it looks like it's really hard, but when we start looking at it, we go, oh, that's really easy. So here's the really easy part about it. ABTC, this polygon right here, what is it? Y'all know what that is? That polygon, that's a quadrilateral. The sum of the interior angles in a quadrilateral, anybody remember those? The sum of the interior angles has to equal 360. So x plus 90 plus 135 plus 90 has to equal 360. Y'all, that's easy. I can solve that, no problem. So I just subtract the 90, 135, and 90 from 360, and that gives me that x is actually equal to 45 degrees. Bam! Easy. So I love these types of problems. It looks like it's really hard, but then as we start to actually try the problem and really start to put pieces together, it ends up being a lot easier than we anticipated. So that's all we have to start out with for tangents. You should be able to do the next few problems knowing the information that we've just gone over. Good luck.